Here's a great example of how a familiar strategy can save us, even if we have really no clue what's going on. We can just kind of go through the motions, trust the process, and the answer hopefully just reveals itself to us. So what do I see when I have this question? Well, maybe I see the circles. That would be great if we understood how the circle equation worked, but we don't need to because we just see that we have an equation and we have 4 points. And so what strategy should we use? How about we say plug points into equations? My favorite strategy, because it doesn't really require a lot of clever thinking. We're just doing it. So I would be lazy and I'd start with C. And I don't really know what I'm expecting to happen here, but I would do it anyway. So I would say, okay, C is going to be the point 0, 0. So that's 0 plus 3 squared plus 0 minus 1 squared is equal to 25. So 3 squared is 9. Negative 1 squared is 1. So this is getting me something weird. 10 is equal to 25. Okay, well, that doesn't equal 25. But okay, I did it, so maybe that's wrong. I don't really know, right? I don't know enough about circles to know. But I'd try another point. Let's try D, right? D is kind of nice. It doesn't involve some big numbers or any sort of, negatives. So 3 plus 3 squared plus 2 minus 1 squared equals 25. So that's 6 squared. 6 squared plus 1 squared is equal to 25. Well, that's 36 plus 1 is equal to 25, and so that gives me 37 is equal to 25. Again, another problem. And we can keep doing this, so let's keep going. I'm going to do all of them. So negative 3, 1. So B, negative 3, 1. So that's, get as much space as I can here. So that's a weird one. That's an interesting one, because watch what's going to happen here. If we do that point, 1 minus 1 squared equals 25. So negative 3 plus 3 is 0. So 0 squared is 0. 1 minus 1 is 0. 0 squared is also 0. So this just gives me 0 equals 25. And that's because this point right here is the center of the circle. And that's the way that this equation works. If we have a circle equation, it generally goes in the format x minus h squared plus y minus k squared is equal to the radius squared. So that hk is kind of the sign gets flipped, but it's giving us the center. So this is really the center of the circle. So going back to the question for a second, we want a point that does not lie in the interior of the circle. So obviously the center of the circle is inside the circle. So that might help us later. Let's just finish the job here and do choice A. I know I'm kind of all over the place with the points, but negative 7 plus 3 squared plus 3 minus 1 squared is equal to 25. Negative 7 plus 3 is negative 4. Negative 4 squared is 16. 3 minus 1 is 2. 2 squared is 4. And so we get now 20 equals 25. So look at this. Look at these things we got. None of this makes any sense. Right? None of these statements is true. So what the heck am I dealing with here? Well, you might know this, but even if not, I think this is a case where just by kind of doing this strategy, we can kind of discover something and learn something about how this equation works. The way that this equation is working is that the points that we would plug into x and y are normally points that are on the outside of the circle, right? So when we draw a circle in a graph, we draw it, and that circumference is what the equation is giving us. So the equation normally is just giving us the outside points. But here they're not asking for the outside points, right? They're asking for the points that are either inside the circle or completely outside of it, not on it, right? And so let me just make this really clear, right? So if I had a circle in the xy plane, this equation is going to give me all these points on the outside, right? An infinite collection of points. Now the h and the k gives me the center, But what we're looking for is a point that does not lie in the interior. So we're looking for a point kind of out here, somewhere out there. And so I would play a little bit of a game of one of these things is not like the other, right? 25 isn't changing. But look at C. We have 10. B, we have 0. A, we have 20. D, we have 37, right? 37 is bigger than 25. In fact, it's the only one of those that was bigger. And the one that we know for sure is inside the circle, the center. That's 0. That's less than 25. So by just kind of like, well, this one's a little different, D would be the smart guess. And the reason that it's right is that the circle formula is kind of like Pythagorean theorem. It's kind of like a distance formula, where the distance, the radius, is constant. And the rest of it is kind of giving us the distance between the point and the center. And so for a point that's outside the circle, the length of that line, the distance between that point and the center, is going to be greater than the radius. And that's going to be represented in the formula by having a number here that's greater than the radius squared. All the other points are less, because if I were to draw them, right, so a point in the center of the circle, the distance between that point, that orange point, and the center is less than the radius. So this kind of blows people's minds, but let me make it really clear. If we know Pythagorean theorem is a squared plus b squared equals c squared, what we're dealing with here is kind of a very complicated way of writing the two legs of the triangle and the hypotenuse. And if we had a circle to go with it, and we knew that the center was hk, what we're really drawing here is an infinite number of right triangles that have a constant radius, constant distance, a constant c between the point and the center. This is not something you need to know for the SAT, but I think it's helpful for someone who's struggling to remember the circle formula, because it kind of relates it to something that's a little easier to remember, right? We remember that a squared plus b squared equals c squared. That's kind of common. That's a very easy formula, not a lot of moving parts. If you can see that there's a symmetry between that and the circle formula, you might remember, okay, there's a plus between the two terms here, right? There's a plus there, and it's the radius squared because it's c squared. So it can kind of nudge you in the right direction for some of the harder pieces. But yeah, that's what's basically happening, is we're making a bunch of right triangles that all have the same hypotenuse and then different legs, x minus h, y minus k, that kind of thing. Maybe it helps. But there you go. That's the real reasoning, is that this distance is greater than the radius, and therefore D is outside the circle.